Hey guys, this is Yusan, and in this video we're going to talk about question 9 from DSP1. So let's start from a much easier one. Look at diagram 2. We only have 1 0 and 1 pole, and the 0 point, it's a real number. So we could find the transfer function like this, with the absolute value of a is smaller than 1, and by using the Z transform we could find the impulse response function. It's decreasing and converges to 0, so we could easily find the impulse response function, which is this one. Now let's look at the diagram 1. In this diagram, we have two zeros. The negative one, the absolute value of negative one is bigger than the absolute value of the positive one. So we could get the transfer function like this. By partial fraction method, we could get this combination. We use C and D to represent the index to show that the index before Z might not equal to 1. So we could easily find the impulse response function. Since this one is just the same with the last one, in the diagram 2, and this one, since B is negative, so when n comes close to infinity, it will change between even odd, and so on. So the value will be positive, negative, and so on. So when we apply this diagram to this diagram, we could see that for the positive points, it will be much higher than the original values, because for the positive points, it will be added by the positive values, and for the negative points, it will be added by a positive points, which means the negative points will be, the absolute value of the negative points will be lower, even close to the 0. So we could find the matches diagram, which is this one. Since all these diagrams are decreasing and converges to 0, so when we apply one to another one, the final diagram will still decreasing and converges to 0. So next, look at the diagram 3. Diagram 8. Since this is the only one that the zeros are out of the circle, which means it will not converge. So we could easily find the matches one, which is this one, diagram 4. And next, we're going to talk about diagram 3. So in this diagram, we have 3 zeros and 3 pole at 0 equal to 1, and 2 of the zeros are complex, this one, and 1 is real. So we could find the transfer function, which is this one. 2 complex number and 1 real number. So by partial fraction, we get this combination. So for the complex numbers, we get the diagram like a periodic cosine diagram, but for the real part, we get the decreasing diagram. So if we apply this one to this one, we could find that the positive point will be much higher than original ones, because it will be added by the positive points. But for those negative points, the absolute value will become much lower than the original one, because it will be subtracted by because the negative points will be added by the positive points. So let's try to find the matches diagram. Which is this one. We could see that all the positive points, it's much higher, it's bigger than 1, and the negative points become positive, and it converges to 0, because this diagram is converges. So next we're going to talk about 5 and 6 together, because for those diagram, the convergence, the omega, which is the angle of this one, is the same with this one. So which means they have the same frequency. Since the distance between the pole and 0 in that diagram 5 is smaller than that in the diagram 6, which means the speed of convergence is much faster in diagram 6. So since we know this equation between the frequency and period, since they have the same frequency, which means they have the same period. So let's try to find that. So in this diagram, we could see that the period is 10 if we regard the unit as 1, because it starts from here and ends at here, and then it converges. The speed of convergence is really fast. And look at this one, because this period is also 10. It starts from here and ends at here, so that is one period, but it's not convergent until more than 40. So the speed of convergence is much slower than this one. So this one is matched with diagram 5, and this one is matched with diagram 6, this one. So now let's look at the diagram 7 and the 4 together, because the biggest difference between those two diagrams is that the frequency, the angle of this one is much bigger than that. So which means the frequency of diagram 7 is much bigger than that in diagram 4, but the period in diagram 7 is much smaller than that in diagram 4. So only diagram 3 and 5 are left. So look at the diagram 3. So it starts from here but ends at here. So this is one period, which means the period of this one is 5. But this one, it starts from here but ends at here, so the period is 20. So this diagram is matched with diagram 4, with smaller, with lower frequency but longer period, and diagram 3 is matched with diagram 7, with bigger angle, the frequency, but shorter the period.